Last week, we did an overview of the Model Context Protocol, or MCP. This week, we are going to dig into the details. On this e-commerce application, we're going to first build tools to connect it to the Products API. Then we're going to build an MCP server to connect to the Orders API and give our MCP client of the web server the ability to make orders. And then we're going to do some business intelligence and take Claude and connect it to that MCP server. It is amazing stuff. Let's get right into it. All right, so here's our example e-commerce application. All of this code is available to you, of course, for free in GitHub, and a link in the description right down below. Now, this is a pretty simple site. We got our homepage right here. You can click on a guitar, see the detail on that guitar, really beautiful. But there's also this really neat AI assistant. Now, this AI assistant is designed to help the customer figure out what guitar they want to buy. So we'll say, can you recommend a techie looking guitar? Now, in our product catalog, we have the motherboard guitar, which would be a perfect fit for that. Let's see what the AI assistant comes up with. Well, the AI assistant right now is telling us that we should go for a Ibanez or a Parker or a Strandberg. None of those is us. Well, we don't actually exist. So what we want to do is give it access to our product catalog. Before we do that, let's take a look at the systems architecture of this to figure out exactly what's going on. So what you just saw there was the front end is a TanStack Start application running on port 3000. It connects to the Products API, which is an Express app on port 8082. So what that allows it to do is get the list of guitars, so you can do the homepage, get guitar details, so you can go and show the detail page. Now, what's missing, obviously, is that AI assistant. That does not connect to the Products API, and that's why it's giving us those off recommendations. So that's job number one. We're going to go and connect that AI assistant to that Products API using tools. And then understanding how tools work, we'll be able to understand how to get tools to work within the context of an MCP server. But before we get into that, let me just quickly finish up the systems architecture as it is. We also have a fulfillment API, again, Express on port 8080, and we have an admin app, also a TanStack Start app, and that's on port 3001. That's going to allow us to take a look to see what the fulfilled orders are. So now let's start talking about how we're going to connect our AI assistant to our Products API. So obviously the front end has no issues right now connecting just directly to the LLM and asking it basic questions. But what we really want is we want that LLM to have access to our Products API. So that's where tools come in. And understand how tools work, you have to understand the message flow of an application. So you've got the client and the server on the front end. The client in this case is the AI assistant, which is, say, for example, that I type in say hello into that assistant. That goes to the server. Server then sends that to the LLM. The LLM then goes on, adds onto that messages list, the message history, that hello, how can I help you, that kind of thing, and it sends that back. Now let's talk about a tool flow. So let's start off with something that requires a tool, like please recommend a guitar. Again, we add that in the messages, just as we did before. That goes to the server. Now the server then sends that off to the LLM, but this time it adds a little bit extra. It gives a tools definition, and those tools are defined at the meta level. They say they exist and what the parameters are, but there's no way to actually execute on those, as we'll see in a second. So the LLM gets the message, it gets the tools, it then sends back as part of that message history, hey, I need to know what those products are, so make a tool call, you as the server, to get the products. You said that you had that tool, please execute it for me. So now the server that does have access to that Products API makes the request to the Product API and sends back the data, and then we take that JSON and we add it into the message list as the result of that tool call. Then we send that to the LLM. Now the LLM has the original customer query. It now has the content from that tool call, and it can go and give us a recommendation as part of that message history. And there it is. That's how the tool flow works with an LLM. So let's actually try this in code. All right, here's the NX mono repo that has all the applications that I've been talking about. The one that we're most interested in that has the AI assistant is the front end. So let's go in there and we'll take a look at AI tool. Now this is a function that returns the tools that are available to the AI. So what we want to do is implement our first tool. So we'll bring in the tool function from the Vercel AI library. We'll bring in our fetch guitars helper function from the APIs. That fetch guitars function makes a simple call to the products on 8082. And now we'll define our first tool, get products, and we'll give it a description to just get all the products from the database. Now that's a good thing for the AI, so it can understand conceptually how and when to use this particular tool. It also needs parameters, so we're going to need to bring in Zod for that. Now, in this case, there's no parameters. You can add any parameters you want and describe them. And then there's an execute function. So tools that run on the server need an execute function. And in this case, execute is going to call that fetch guitars function to go and get the data from our products API. Now we add that to our object that has all of our tools. And now we just need to go and take this over to AI.ts and bring it in. So import get tools. And then we'll go down here to where we actually make the call to the AI. Now, our call to the AI uses Vercel AI's stream text function, and it gives it the model, in this case, Anthropic. You could use OpenAI. You can use any model you want. It just has to have support for tool calls. We give it the messages, which would be that array of messages that we saw. There's a system prompt. In this case, the system prompt is, so far, you're an AI for a music store. Now, I'll get to max steps in a second, but let's go and get our tools, and then we'll give them to the AI, and let's see this actually work. So we'll go back over here to our arc. We'll go to our AI assistant, and this time, again, I'll ask it for a techie guitar. All right, so it's saying that it's checking our product catalog for guitars that match that description, and there it is, the motherboard guitar. Awesome. So it's made the right choice, and now it's working off of our product catalog. Awesome. Now let's go back into the code, and there's two more things I want to talk about. And the first is the system prompt. Sometimes it's good to actually hint to the AI that you want it to use those tools. So for example, you can say there are products available for purchase. You can recommend a product to the user and then tell it to use that get products tool. So if you're having issues with it not using your tools, then you can go and add some extra reinforcement in your system prompt. Now, the other thing is around max steps. So we went all through the flow here, and you can see the highlighted section is around the tool call. Now, there's actually multiple steps that the AI needed to take to accomplish the query. We said, please recommend a guitar. So it had to do step one, request a tool call. That got back the tool call data. And then step two was to analyze that data and provide that recommendation. So you have two steps there. And by default, the AI library limits the number of steps to one. So if you're going to use tool calls, I strongly recommend setting max steps to something more than one. All right, so far we've been talking about what I call server tools. And those are tools that are run on the server. But there's another type of tools, client tools. And client tools, as you might guess, are run on the client. I mentioned them in an MCP video because it's important to understand that MCP is not good for client tools. MCP is good for server tools. MCPs run on either servers or on your command line. They don't have access to the client by default. So you need to understand that client tools exist and what they might be useful for. So let's take away the server and let's try a new tool call. This one's called recommend guitar. After it's figured out what guitar you want, maybe there's a new tool call that allows it to go and on the client have a special card that says this guitar in particular, right? So what we're going to do is we're going to have a recommend guitar tool call. It gives us the ID as an argument, and then we put in a nice card there that shows the guitar and allows them to go into the view detail page and see more about that guitar. Let's give it a try. Let's go back into our AI tools and we'll create a new tool called recommended guitar. Use this tool to recommend a guitar to the user, and it'll have an ID as a parameter on it, and we'll tell it that that is the ID of the guitar you want to recommend. Now we'll add that to the list of tools. And the next thing we need to do is actually go over to the UI and make sure that that is accounted for. So we'll go over to our AI assistant. We'll scroll down to the use chat hook. That's where we make the actual request to our Gen AI response server function. And then we'll add a new message handler called on tool call. And it says, hey, when you get a tool call recommend guitar, just say, we are going to handle that on the UI side. Now you could actually take some action at this point. If you had, for example, a GPS tool, it can make a GPS call and then add on to the messages the result of that GPS call. You could actually do things on the client. But in this case, we're just going to have it recommend the guitar. To do that, we're going to go back to our messages component, which is right here at the top. It shows all the array of messages, and we're going to go right down below where it actually shows the text of the message. And then we're going to add on that if we have any additional parts to the message, which would involve tool invocations, we're going to see if that type is a tool invocation and if it's recommend guitar. And in that case, we'll use our guitar recommendation component and give it the ID. Let's go bring in that guitar recommendation component and see how our new client tool goes. Let's go back over to our AI assistant and again, ask it for a techie guitar. All right, looks like it's got the correct guitar and awesome. It's got our card in there. It's in place, looks great. Let's go and click on view details. Beautiful. That's really what you want. That's what you want from an AI assistant. You want it to actually be integrated, not just be text, be multimodal. It's beautiful. But what you also want from an AI assistant is to be truly helpful. In this case, it would be really great if it could allow us to make an order. So now I've got this techie guitar, let's go buy it. So back to our systems architecture diagram. We fixed the issue with it connecting the AI assistant to the products API, but now we want it to connect to the fulfillment API so that we can actually have that AI assistant make orders on behalf of the customer. But it can't do that currently because it's got no connection. So we're going to try tools again, but we're not going to put them inside the server. We're going to put them inside an MCP server. So here's the flow that we saw before. There are server tools. The server is going to get a tool call request to say order a product. It's then going to make a request to the MCP order server to handle that tool call. That MCP order service is going to talk to that orders API and send it back to the server. So the flow is basically the same. We're just putting that MCP order server in the middle of that flow. The big advantage of having that MCP order server in there is that the front end in this case is only one client to that MCP order server. You can have others like Claude or Cursor or Windsurf or any other MCP client. Because in MCP parlance, all of these are MCP clients and all those connections are transports, part of the transport layer. Now, the first transport that we're going to take a look at is SSE. So we're going to have our front end server talk to that MCP order server over SSE or server sent events, which is running over HTTP or HTTPS. I'm going to go into the apps directory and I'm going to create an MCP order server. I'm going to do PnP init to initialize that project. And then I'm going to add some required libraries. The Model Context Protocol SDK so that we can build our server. Zod so we can specify the parameters. And then Express because we are SSE MCP server and we run over HTTPS. So Express is going to handle all that for us. Okay, let's go in there and I'll create a new server.js file. And I'll bring in MCP server so we can define our MCP server. MCP server is a class, so we're going to use new to instantiate an object from that class called server. And then we can define our first tool. We'll call it get inventory. It gets the product inventory and you give it an execute function. So in this case, we're just going to call off to inventory and get the inventory and then pass that back as textified JSON. We'll also get a purchase tool. So now a customer can use that MCP server to purchase a product. I have to specify some parameters, in this case, items, which would be all the items in your cart. So each guitar, as well as the quantity, as well as a customer name. Obviously, you'd want more than this, but this is fine for a demo. And the implementation of that, again, calls 8080. In this case, the endpoint there is purchase and just sends along the data as the body. All right, let's fire this up by first creating an Express server. We'll set it up to listen on port 8081, and then we'll create two endpoints. The first is a GET request to /SSE. That will create the start of the stateful connection between the MCP client and the MCP server. Now, there is a PR in flight to make a stateless variant of this, but currently is a stateful connection between those two things. In addition to /SSE, we'll also have /messages, and that's where the MCP client will post messages that come in and get those responses back. So there we go. Code-wise, one last thing to do before we get this fired up is to make this a type of module in the package JSON. And now we can run it. Let's give it a go. Node server.js. Excellent. Now it's running on port 8081. Let's take a look. And we get this nice little thing that tells us, hey, you're connected. And when you want to send me messages, talk to this data endpoint. Cool. Okay. So let's fire it up and let's go connect it to our front end server. So go back over here to our AI tools. And bring in the experimental MCP client from AI, and then we'll run that experimental create MCP client function and tell it that our SSE endpoint is on localhost 8081. We'll call it an order service. And now all we need to do is go down here to get tools. We'll await the tools coming back from that MCP client. We'll add them to our list of tools, and now we can go and make orders. I do want to go back into AI though and make sure that in our system prompt, we're telling the system to use get inventory and purchase. All right, let's give it a go. Now, before we do that, let's go over to our admin server. So here's our admin server with our inventory. We got 5 units of this, 9 units of this, so on and so forth, and our orders. So we expect to see a new order come on up here if this works. So, okay, let's go and say, please order me 2 motherboard guitars. I'm really in love with them. My name is Jack. Okay, so now It's going to check the products in the inventory. Awesome. So it's going to the inventory and it sees that the motherboard guitar is available in the stock. And it has now made the order. It's $1,298. Let's go take a look at our, yeah, there you go. Look at that. Fetching the inventory, purchasing. Fantastic. This is great. Let's go take a look at our orders to see that that order came in. There we go. So now we see the same types of tools, but working on an MCP server and the web server, in this case, an MCP client using that MCP server. Now there is another type of transport, and that's STDIO. And to demonstrate that, what I want to do is do some business intelligence through Claude. So Claude is going to use a STDIO request to MCP order service. Let's give that a try. So back over my code, I'm going to stop that MCP order server, and I'm going to go and extract the logic from here. That'd be the server. And I'm going to create a new file called server logic. Paste that in there. Now server is exported, so we can just simply import server from server logic, and this should still work, but we're going to call this SSE server. And then we're going to make a new one called STDIO server. It's going to bring in the STDIO server transport from that Model Context Protocol SDK, as well as that server logic. Then we'll create that transport and connect our server to it. To see that it's all working, I'm going to go over my command line and run it. And I see nothing, which in this case is actually good because it's waiting for standard input to actually drive this. So let's go and generate some standard input by going over to Claude and connecting that to Claude. So over in Claude in settings, I'm going to go to developer and then edit the config. To edit the config, I use whatever editor I want. So I'm going to use cursor for that. And I'm going to give it my MCP server. So I'm going to define that I have one MCP server called orders. The command is node, and the argument is the absolute path of that particular JS file. Now there is one more thing I want to do. Over in server logic, I want to go and add another tool so that Claude can have access to our orders. So I'm going to take this, get inventory, and I'm going to copy and paste it. We'll call it get orders. Get the product orders. Return those orders. Fetching orders. That looks good. Okay, so I think we're good to go. So let's go back over to our Claude. And now I need to restart it so that it reads that configuration file. And now that I've restarted it, you can see that we have this little MCP icon down there. I can see that we have the fulfillment MCP server attached. Awesome. So ask it to analyze our orders, to draw me a graph of our sales and project next month's sales. Let's see how it does. I've never actually tried this before. Okay, so it's asking for permission to call that tool. Great, allow it. So it's called that get orders tool. It's got our orders. Excellent. Now it's processing those. Oh, this is so great. It's actually writing some code for us. This is really cool. Okay. Generating some JavaScript. This is awesome. Fantastic. Okay. Looks like we did okay in January. We're doing okay in February. March is on the rise. That's great. And April, it's not looking so good. A little bit down, but that's okay. Obviously, this is all just fake data, but oh my gosh, that is so cool. Check out what we've done. We've added business intelligence as well through our MCP server. I even liked how it used blue in the bar chart, blue color coder. That's fantastic. All right. I hope you enjoyed this applied look at the Model Context Protocol. It adds some more depth to the overview that we did last week. Now you know more about how to create servers, how to create clients, how to use your MCP servers in multiple contexts, how that message flow works between the server and the LLM. If you have any questions or comments, please put that in the comment section right down below. And in the meantime, if you like this video, hit that like button. If you really like the video, hit the subscribe button and click on that bell and be notified the next time a new Blue Collar Coder comes out.